How does ice melt affect ocean salinity levels? Imagine a world where the ice in the polar regions is melting faster than ever before. This change is not just about losing ice. It impacts the entire ocean system in ways we are still learning about. When ice in the polar areas melts, it releases fresh water into the ocean, which can lower the saltiness in that specific area. This process is called freshening, and it happens mostly with sea ice, which forms from ocean water. During freezing, most of the salt gets pushed out, so the ice is mostly fresh. When this ice melts, it adds that fresh water back into the ocean's surface, making the water less salty nearby. But the story gets more complicated because regional ocean currents can change how salinity behaves. In some places near Antarctica, scientists have noticed that despite melting ice, the ocean has become saltier. This is because ocean currents are bringing saltier water from deeper layers to the surface. When this happens, the surface water becomes denser, which allows warmer water from below to rise. This warmer water then melts more ice, creating a cycle that speeds up ice loss and alters salinity patterns even more. When land-based ice like glaciers and ice sheets melt, they add large amounts of fresh water directly into the ocean. This can significantly lower salinity levels and contribute to rising sea levels. Floating ice, such as ice shelves or sea ice, when melting, has a smaller effect on sea levels because fresh water is less dense than salt water. This means the volume of meltwater is slightly larger than the volume of seawater displaced by the ice. Overall, melting ice changes ocean salinity by adding fresh water that dilutes the saltiness. However, regional ocean circulation can bring saltier water to the surface, making the pattern more complex. These shifts in salinity influence ocean density and currents, which are vital for regulating climate and weather patterns worldwide. In the polar regions, these changes are reshaping marine environments, affecting sea ice stability and the flow of ocean currents. As the polar ice continues to melt, the ripple effects will reach for beyond the icy edges, impacting the entire planet's climate system.